Well, hello. This is the first devlog of my new project here. I'm just going to go over what I did today. It's a fresh project. I'm using existing modules that I've created over the past few months or a little over a year. But it's a new game project, and so I just kind of wanted to go over like all the, you know, from the beginning, like where it's all starting. We'll see how it ends. So today was mostly about ECS and immutability. Were the two things that I crafted. Let's call it. I wasn't planning on using going heavy into immutable data structures on this project yesterday, but this morning when I woke up and as I was kind of thinking about it in the shower and so forth, I decided that I really do want to focus more on immutability. I think that was I think that will force me, and like it's a good constraint, right? It forces me to kind of do things properly, and I think that'll pay dividends as I go forward. We'll find out. It might be too much of a constraint for game development, but I think I can do it and make it perform and so forth. The other thing is the ECS system. There's lots. It's just a pattern, right? So there's lots of ways of doing an ECS system. I kind of did some Googling and so forth, and kind of looked at some existing systems, and watched some YouTube videos on, or I've been watching actually YouTube videos on how to implement ECS systems and so forth, because that's just one of the things I was interested in almost from the beginning, right, of this journey. And I've had a go before creating an ECS system that I wasn't particularly happy with. It was kind of overly complicated, I would say. So that in my last project, it was sort of an ECS system, right? So I had systems, and I had an entity, and I kind of had components, right? But the components were really just my entity was an object, and then I had things hanging off that object that had names, right? You can kind of think of those as components to some degree, right? Because I was just doing type checks to figure out whether or not it was a thing or not. This time I'm going with a more radical structure. So let me, and I think it is kind of radical. I haven't seen anybody else do this before. So let me get into the code here and kind of show you what I'm doing here. Let's try to do it this time without turning my audio off. So this is the second go round of this, because I was swapping around screens, and I didn't have the video up, or the audio up, and now I can't get the video to work. Oh, it's because I did this. Man, this OBS, man, it's a you gotta treat it with care here. All right, so this is my screen. Hopefully you can see my screen. Or OBS says you can see my screen, so I'll trust OBS. Let's see here. You know what? Let's start off. Let's maybe even make this a tradition to some degree. Let's get some tea. Again with the Earl Grey with the heavy cream. Oh, that is so good. If you haven't tried it, I recommend it. You should give it a go. Oh, it just feels good. All right, so let's start from the beginning of the beginning. Let's start from the beginning of the beginning of the beginning. So this is my package.json. So this is, it's pretty simple. I have a lot of, like I said in the last devlog, a lot of these dev dependencies are just webpack junk that I don't like, but I have to have, or think I have to have. And then these are all my dependencies for all the, various modules that I'm pretty sure I'm going to be needing, or at least a lot of them I'm going to be needing. The new one I created today was the ECS module, so that's a new one. I also did a lot of refactoring of my math library, because I was, as I was getting into thinking I was going to do more immutable stuff, I've never really been happy with my math library, because it doesn't force immutability, so it sort of allows you to mutate its vectors and point objects and so forth. And I've never really been happy with the fact that you could cheat with it. But it turns out, as I was kind of going down this path of trying to mutatize, is that a word? All the things. I just went ahead and I did a nice clean refactoring of my math library, and I'm happy I did that. So I kind of cleaned it up quite a bit. Maybe I'll show that off in some future devlog, because it's kind of it's nice. I like it. I'm kind of proud of it. Anyway, so lots of modules and so forth, but let's get into like just from the beginning, right? For like the way I'm using Webpack and so forth, I don't do an index.html. I just have Webpack create a dummy index.html on the fly for me, and then I just like get access to the document.body, and I do everything in JavaScript, so I don't do any HTML work. So the way that, here, let me just go over the project organization here. So I have, this is the way I'm doing it currently. It seems to work out pretty good. So I have an index.js. It seems that this is just a good practice, I think. Always have an index.js is at the root of your project. It just seems to make everything nice and easy. So I have two separate, you want to call these submodules, whatever you want to call them. I have hanging off of here, game and app. It seems like having a clear separation between the kind of the application of the game versus the game of the game. Like the application would be something that handles like windowing and stuff, and it's higher level, just kind of businessy sort of stuff, let's call it, of your application. And in the game, I'm kind of liking for just like the pure game aspects of the thing that we're creating here. And so I'm doing a kind of a more clear separation this time of these things. The last go around I had like all the stuff like outside on the source folder, but I think kind of keeping the game sort of stuff inside the game module, I think is going to be nice. So the app has, so index, right, calls app main, right? App main calls game main currently. So currently app main doesn't do a whole heck of a lot. Eventually it will. So you'll see this animate's got create, like I said, I won't even say that anymore. Who knows who watched the previous devlog, right? So animates.create is essentially just my wrapper around request animation frame. So let me show you some of the code here. So the it's not super complex or anything, but effectively what it allows me to do is do a frame rate of my choosing, right? So essentially this is the interface to it, right? It's like, here's how many ticks per second do you want? Just give me one or multiple tickers, right? So you can have one ticker or multiple, just give me some things you want me to call on every tick. I have just this very basic sort of rudimentary pause. It's running or it's not running. Then I have an error handler, and then I also kind of abstracted out whether or not, like, what function you want to call to request the animation frame. I'm not sure that's strictly necessary, but who knows, might come in handy later on. Anyway, so that's that, and that's how that works. Right now you can see that this does absolutely nothing. There's no point in me having this right now, but eventually it'll probably have something. In my last one, I had the application itself kind of running at like 8 frames per second, right? It was mostly just doing it for like debug, console logging, or on-screen logging sort of stuff. So that's kind of what I had it using it for. So the game, right, which will probably run at 60 frames per second would be my guess, starts here. And so this is here, let me kind of get rid of this comment. This is the game proper, and this is how I'm, this is the very beginning of things. So one of the things let's just go from the top to the bottom, and I think it'll explain how all this works. So this is basically all the code that's needed to get this thing rendering, right? My box entity is just a thing with a position, right? I have a pool, which is my entity pool, right, of just this box entity. I have my systems of that I'm doing right now. I just have one that rotates the box, right, and one that renders the box. And I'll go into each of these things in a little bit more detail. I'm just going to give you the overview to begin with. I have my tickers. So last last go round, I had several tickers going at various frame rates, and so I'm just sort of preparing for that right now. We'll see if I keep that or not or whatnot. But anyway, so that's what that's all about. And then I kind of have my the main ticker is just the ECS ticker, right? Right now it just takes the pool of objects and the systems, and then it just sort of executes the pool over each system, if you want to call it that way. So note the way that I'm doing this, and this is 100% because I want to keep this an immutable system. Note that the system takes a pool and returns a pool, right? So I'm passing in the pool. The system is looping over the pool, but it's returning a pool. And this is because this pool is immutable, right? In fact, I should probably, that is an entity. Entity. Oh, I'm doing it wrong. I always mess that up. I already have it. Yeah, I already have it properly typed here. So this is an entity, and I'll get into how I'm doing immutability, but just know this is kind of very, very immutable. It's frozen, and it's frozen from the JavaScript object standpoint of immutability, and it's read only from the TypeScript type immutability stance, let's call it. So this is an immutable pool. This is an immutable data structure, right? And so I'm passing in an immutable data structure, and I'm getting back an immutable data structure, but I'm replacing it every time, right? So this, if you weren't aware, this is effectively like doing a let in, in the scope of the project, right? So I could let foo equals blah. It's like that, doing that, right? And so I'm just replacing that argument variable every time. So it's just kind of I don't know if it's a hack or a good practice of doing it that way, but it works. Let's call it that. And so, I'm just looping over every system, kind of gets a pool. So right now, the rotate system does the rotation, and then the rendering system does the rendering, and then, it just kind of loops on forever. So let's get into, let's start with the immutability. First of all, let's start with a little bit more T. Whoops. There we go. Mr. Earl of the Gray. Good stuff. All right. There's your ASMR of the of the podcast, or the whatever you want to call this. So, unfortunately, from the let me save this real quick. From TypeScript's point of view, read-only is just a type, and it's only going to do type checking. And so you're not protected from runtime mutation of objects, right? But JavaScript has object.freeze, right, which does protect you from runtime mutation, right? And they're I don't know. I mean, I guess I kind of do know why, because TypeScript is wanting to be very clean in the code they're emitting. But I really wish there was a way to emit object.freeze whenever you have a type of read-only, right? So if you're not aware, TypeScript has a read-only type, which like enforces immutability, read-only nature of types. But I want them combined, and so I combined them, and so this is how I did that. And it's kind of is it a hack? Is it clever? I don't know, but I think it's going to work. So I have this thing in my here's the thing to kind of go off of. Note that I'm outside the package, or outside this particular project scope, and this just has to do with the way that I'm doing my modules, but allows me to edit other modules outside the scope of this particular project within, very quickly edit them within this project, right? And the way the trick to doing that, if you're curious, is just do an import of your project, right? And just do an npm import. It'll probably work with Yarn as well. I just haven't moved on to Yarn yet. The thing, and it'll do a file reference, right? And then it just all seems to work. That if you if you go into the thing, the function or what have you, it'll actually look at your npm modules and kind of do the right thing. So it's just kind of nice. It works out nicely. Anyway, so that was sidetrack. So I'm doing an object.free. So it's very simple what this fixed thing does, right? And then I have this fixed type. Now I thought that would just solve it, but the problem is that TypeScript is what's called structurally typed. And I kind of discovered this today, right? Is that TypeScript is structural, or I kind of knew it, but I didn't maybe know the right word for it. So what that means is if it walks like a duck and it quacks like a duck, then it is a duck, right? Kind of typing, right? So it's if the structure A looks like structure B, then they're equivalent. And so unfortunately, this fixed type kind of looks like read-only to TypeScript, and so it won't enforce this object.freeze, right? It won't enforce this fixed type, but I want it to enforce, like the only things that are called fixed, I want to go through this object.freeze, right? And that's it. I don't want it to be just like it's read-only. So here's the magic for how to do that, if you're curious. And this is the guide. And I'll try to remember to post this in the notes, but if not, here you can take a screenshot and go to this guy's website. This Michael Zalecki, I'm butchering that, I'm sure, but anyway, clever fellow. And so this is how to do what's called nominal typing in TypeScript. And by nominal, I think what's been is effectively just you're using the name of the type, right, versus the structure of the type, and you're kind of enforcing that. And here's it's effectively just a hack, right? But it's kind of what you have to do in this day and age. Apparently, Flow has something called an opaque type that kind of handles this. And I don't know, maybe TypeScript will get it eventually. But for right now, this is how you kind of do it. And actually, this is one of 4 ways of doing it. And this article kind of goes in the other ways. So it's worth checking out that article, I think. But effectively, you do what's called branding of the type, right? So I have the type and this extra little bit. But this extra little bit is absurd, right? It's never going to happen, right? You can't. There's no value that corresponds to void, so you can never set this property on here. And the TypeScript compiler and so forth is smart enough not to admit anything, and to kind of be okay when you create something of type fixed that doesn't have this property, right? Which is kind of, it's an elegant hack, let's call it. So that's how you do the type itself. And then this is my type guard for it, right? Where I just say this is my mechanism for doing type guards. Is I usually I create what I call a straw, like a straw man of the type. Right? So I just say this is this, right? And then that just makes it nice because then I have access to if there's any properties or it should look this certain way. It kind of gives me when I'm doing my actual coding check of the thing. It just allows me to get access to the type itself. And then if I change the type, but I don't change the type guard, it means it's going to have an error, right? As TypeScript goes about compiling, right? And so then I get an error, right? So that's just kind of nice. Type of straw equals object, and then I just make sure that it's frozen, right? So that's how you do that, and it's kind of clever, and I like it, and it's very, it's probably like 10 lines of code all in, and I think it's going to work well. I'm pretty happy with it. Now, the one thing I'm not very happy with is the syntax, right? Oh man, this sort of butchered up what should be as something as simple as, like, if I just do, let's get rid of the type, right? Let's call it box entity 2, right? And let's just get rid of all the garbage, right? So this shouldn't be here, and this shouldn't be here, and I don't care about this, and this needs to go away, right? It should be that, right? Oh, that's so much better than all this garbage, right? Because I have to do this fixed stuff. But this is well and truly fixed, right? It's solid. So I'm probably going to create some sort of convenience functions for taking this mutable data structure, right, and making something pretty immutable that's, you know, fixed, right, off of it. But for right now, this works. It's ugly, but it works. So, you know, you can see I'm starting off my pool with this simple box entity object. Then I have my system. So let's go into the systems. So this is my rotate system, right? Which, you know, my system, just to kind of tell you what that's all about here, you can see in the type, it's just a thing that takes a tick in a pool of entities, right? And produces a pool of entities. Now, I'm not very happy with this any. I would much prefer the system to be either like to be unknown, really, is the proper value for this. But I just ran into some issues with the type system, and this just sort of gets around them for the moment. But know that bothers me. So this is the system, right? So all I'm doing is I'm mapping over the pool, right? So remember, this is a read-only data structure, or immutable data structure. I'm doing this update, right? So I have to have a way of kind of cleanly updating stuff, because I'm going to want to replace stuff. And so the way I'm doing that is I have this update entity function, which I'll go into here in a bit. But you can just, at a high level, it just takes the type guard, the actual entity, which, remember, this is an array, right, of expressions. And I didn't explain what an expression is. I need to explain the expression, I believe. I'll explain that, right? So that probably needs some explaining right now. Stateful objects. I mentioned this before, but I'm really kind of the point of view in this moment, at least, that for stateful objects, having a programming interface into a stateful object is not a bad way of going. And so, you know, to kind of view the state as a list of expressions, right, that is kind of built up over time, and you know, and then you kind of, you know, execute the expression in some sense, right, if you want to think of it that way. So this is my expression class, and you can kind of see here I have an example. Here I was just showing that in my previous one where I didn't have audio, which hopefully I have audio, this I actually have an example here, which I'll go into. But, you know, just for the moment, just let's get this out of the way so you can focus on this. The expression, right, I'm just doing EXPR to be short about it, is just something it's a string, right? And then it's some sort of type. And one of the things that I've kind of more recently started doing is actually having default types in the types. And that just works so well, because you can just kind of get into typing hell if you force types all over the place. That's one of the great beauties in my mind of Typescript. I mean, that's the genius of it in some sense, that it doesn't force you to do types when you don't need to, right? And so this basically means that you're not forced into generics if you don't need to. And so I just like that style of programming where it's sort of like opt-in instead of demanded, right? And so here's the, you know, you have what if an expression is, so it's fixed. So remember, this means that it's immutable, right, of n, which is a string, right? So and then again, fixed, right, of some sort of value. So think of this as the function name, and then this is the function parameter, right? And so this is an example of how to do this. Let's see, I kind of messed it. I was showing off how it wouldn't work if you didn't do it right. So I remember. Yeah, let's do this. So foo. All right, so expression foo equal foo. There we go. So that should have worked. Why did that not work? Oh, it's that horrible thing where it doesn't do the example like you want it to. Anyway, if I do number, I think that'll fix it. It did not fix it. Why is that unhappy? Oh, I know why it's unhappy. Because it's not fixed. See, this is where I don't like this syntax, right? It doesn't it's not giving me the error messages I need to give it. So anyway, so this works, right? And I believe this will also work, right? Yeah, so this will also work because it's defaulted to unknown. So this means that foo is now going to be unknown, right? But if I do this, number, foo will now have a type of number. So that works pretty well. So I'm pretty happy with you know, my expression type, let's call it. And then you can kind of see, you know, how I'm doing my type guard. I'm not, this is a little too clever type guard, I think. I think I'm going to create something simpler, but this works, right? It's you throw in your thing you're trying to type, you see whether it has a name, and then you have a type guard of the actual type parameter, right? So this is the parameter type guard, and then this is the name of the function, and then this is the thing you're trying to test. So so that's how my expression works, right? And so I'm viewing the entity. Let's see, entity, yeah. My entity is just a collection of this. This should be an expression, but I'm running into issues with the type system, and I'm being very, you know, complicated and clever with my types and so forth. And so hopefully I'll get this hammered out at some point. But anyway, so it should just be a fixed set of expressions. Imagine this T is expression. It should extend from expression, but it just doesn't quite work at the moment. And so that's my entity, right? So in a lot of ECS component, you know, entity component systems, the entity is effectively just an ID, and then you have components sort of associated with that ID, and you can kind of do it any way you want, I think, right? It's just, you know, it's just a way of doing stuff, right? There's no hard rules about it. So the way that I'm doing it is I'm trying to see if I can get away without doing an ID, right? And you know, if I have this, it's all immutable, right? Maybe there's no reason to have an ID except for in kind of rare circumstances when I need to relate an entity to another kind of distant entity that isn't a child or something like that. That I might need an ID, but if so, then it's just another component, right? There's no different from any other component. But anyway, so that's the way I'm doing my components, right? It's just an entity is a list of expressions, right? And so that you can kind of think of that expression as the entity, or as the component rather. And then the system kind of works over the list of entities, right? And in each system, like let's look at the rotate system, right? The rotate system goes through and updates the entity, each entity, right? Which just with this thing, I'll go into the function in detail, but the actual let's see how are we doing on time? 28 minutes. Yeah, let's try to get this going faster here because we're almost done. The update entity, essentially I need a way to actually mutate the immutable thing, right? Which is essentially just create a new one and replace the bits that you want to replace. So that's essentially what this does. You pass in what, you know, a type guard of what you're looking to change, the entity, which again, remember, is just a list of expressions, and then here's the expression, and you can kind of get the parameters. So the parameter of the position expression, right, is so here, let me go into what the position expression is. Just an expression that has a position for the name, right, and then a point to, which is a vector or a vector linked to, right, or it could actually be an object. In my math system, I'm very I tried to be very forgiving, right, very accepting of what you know, what a point is, right, and so forth. So I can either be an object or a vector, but I want to, you know, here's you know, another little example of my math library, right, where I can create this thing which is a point to into a vector, which then I can just what's it called when you do this? Anyway, make them into you know, X and Y, right? So then I update it, right? So I have my updated value, right, where I'm just creating a new position expression of a position and point to. So here's the position, right, and then I'm fixing again the position, which here I'm just using the frame count and times a small value to kind of get that circle rotation, right? And then I just return the updated value, right? And then I return from this update entity, which essentially just creates a new entity in place of, right? And because I'm doing a map, right, for any entities that have a position, they will kind of go into a circle. Right now, I just have one entity. So it's going to rotate all of them, right? So, obviously this is just sort of a test system. So the render, kind of more or less does the same thing. It's just, but it's just creating a, here's my example of my HTML module, and I just do things on one object, right? The nice way of dealing with HTML elements, I think. But you can kind of see what's going on here, right? Where I'm just creating the element and I'm just setting the position to the X and Y of the parameter. Here I'm doing this update, but I'm not actually updating. I'm just viewing it or whatever. But maybe I'll create another function that doesn't actually return anything, because right now this doesn't return anything interesting, right? So it just returns the pool, right? It gets the pool or it returns the pool, but it does a side effect, right? So sometimes you got to do side effects, and even in functional programming, this is how this does the job, right? So so there's the text rendering system, and I think that's basically it. I think I've gone over what I've done today. Here's again to kind of look at the beauty of what I've created for today. I'm actually pretty happy with it. I'm pretty happy with the progress. I was kind of thinking I was going to, get to the point where I could draw a cube on the screen, right? That's sort of a nice milestone. But I have this text thing drawing on the screen. That's good enough, I think. Kind of gets things going. So tomorrow is probably going to be thinking about how I'm going to deal with like Matter.js and Three.js, right? Which are kind of beasts in their own right. And the problem with these two things, that problem, let's just say the challenge, let's call it, of these two things is that they each have their own view of the world, right? That they have their own context is the problem. In Matter.js, like, it's pretty explicit. It has a world object, and you have to update the world, and you create what's called a body to correspond to the physicsy thing that you're dealing with in that world, in that system. And so that's kind of okay. But it's still, how do I relate like a collision box like I'm going to create in with the entity, this immutable data structure and so forth. And the problem comes like when you get rid of the things, right? So that's like, you got to clean up afterwards. You got to dispose. And so how you dispose cleanly when you get rid of your entity is kind of the challenge I discovered in my last go round. And so the way I handled it last time was I essentially just like for the mesh, for instance, right? I just put the mesh directly on the entity object. This go round, I'm gonna, I might do something similar to that or something. I'm not sure exactly how I'm gonna handle that. One of the things with Three.js in particular, I'm gonna have to kind of rewrite my module, or not rewrite, add to it a little bit, is unfortunately Three.js has a context that's hidden. And the problem is that like your geometries and your texture objects and so forth, those, you'll note those have a dispose method that you're supposed to call when those go away. And so it's real unfortunate that's hidden in Three.js. I don't particularly like that. So I'm gonna have to I want to create a kind of a little wrapper or something around that, so that I can dispose of objects more cleanly, or kind of make it more explicit. Like with the matter.js world object, it's sort of explicit what's inside the what's inside the world and so forth. Where with 3JS, it's a little bit more hidden, a little bit more cryptic. So I want to kind of make that a little bit more visible and maybe handle it a little bit better. Last time for like 3JS, I handled like geometries and textures by just caching everything. And that works, I think, to a certain degree when it's very small and you don't have very many geometries or textures or whatever that you're dealing with. But eventually you probably will want to dispose of some of that stuff and get rid of it. And so I need to have a think about how I'm going to do that a little bit more cleanly this time. So that'll probably be tomorrow, or maybe it'll be something else, who knows. That's the challenges that are kind of readily apparent in this moment. So anyway, so how long did this turn out to be? Oh, 35 minutes. So anyway, if you stuck around this long, well, I appreciate it. Thanks for your time and attention. And if you have any questions or want me to go into more details on any of this, I'm happy to do that. I'm kind of proud of my little baby here I'm creating. I want to show him off. Anyway, that's it. That's going to be it for right now. And I'll probably, maybe I'll try these daily things, or maybe every couple of 2 or 3 days or something like that. See how that goes. Just see how people react to it and see if I'm having fun with it or not. Anyway, catch you guys later. Bye.